AB Calculus, Notecard 62, Fundamental Theorem of Calculus. This is the 62nd video lesson in the series inspired by Stacy McMullen, formerly of the Dallas Independent School District, who developed the Notecard system. If little f is a continuous function on the closed interval from a to b, and big F is an antiderivative or an integral of little f on that same closed interval, then this is what we have below. And let me just go ahead and put another notation possibility. We could also say if little f is an antiderivative of f prime of x, or if f prime of x is an antiderivative of f double prime of x. That could also be used. And oftentimes we're going to see in the physical world this little f represented as a rate. Then big F would be an amount based on that rate. So that's just something to look out for in the physical world. And then we have the integral from a to b of little f of x dx equals big F, or the integral of this little f of x of b minus the integral of a. And so we have big F of b minus big F of a, which is interpreted as a change in the quantity over the interval. Graphically, this means the signed area bounded by x equals a, x equals b, y equals f of x, and the x-axis. So I'm going to demonstrate what's happening here with a little coordinate plane, xy. We have some function here, f of x, and we have an x value of a, farther on down x value of b, and so we have a vertical line segment emanating from a and emanating from b. And so the integral is this area bounded left and right by a and b respectively, and bounded above and below by f of x and the x-axis respectively. So let's go into some problems making use of this very important tool in calculus. Evaluate the integral from 1 to 2 of quantity 4x cubed minus 6x dx. So we're just going to go ahead and do that. And again, according to the Fundamental Theorem of Calculus, we'll call this A limit below, and this 2 above we'll be calling B. So the integral of 4x cubed is going to be 4x to the 4th power, and we divide by the power that we raised to, minus 6x squared divided by 2, and then we also have our constant of integration c. Normally you don't see it this way, but there's a method to this, and we're going to evaluate between the limits of a to b, which we rewrite as 1 to 2. So we've just put this a value here and this b value here in place of the 2. Okay, now, continuing to work below, this 4 over 4 cancel to be 1, so we have x to the 4th power. We have minus 3x squared plus c, and we're going to evaluate between 1 and 2. Now we're going to, working to the right, put in f of b, and that's going to be x, which is 2 to the 4th power, so we just put in that 2 here, minus 3 times 2 squared, and that 2 also goes in for this x, plus c. And we're going to subtract out, okay, this is going to be our big F of b, and we're going to subtract out, I'm going to parenthesize all this. We're going to have 1 to the 4th power minus 3 times 1 squared plus c. And our 1 comes from this a value here, and also goes here. And just working to the right and simplifying, we have 2 to the 4th power, and by the way, this is big f of a. And so I hope this diagram demonstrates how we're making use of this concept here in the prior page. Okay, we have 2 to the 4th power 16, and then minus 3 times 2 squared, that's going to be minus 12, and we have plus c, and then we have minus, well, this 1 to the 4th power is 1, minus 3, that's going to be negative 2, and plus c. And working below, we have 16 minus 12 is 4, so we have 4 plus c, and minus negative 2 is plus 2, and minus c is going to be minus c. And so the c minus c will cancel each other, and we're left with 6. Now normally, you don't see c used at all with what we call a definite integral here with the fundamental theorem of calculus. But I wanted to put in c just this one time to show how that constant of integration gets canceled in the process. So even though you don't see the c put in there in the definite integral, it really is there, but we don't even put it there any further because it gets canceled out in the process. Problem 2, the integral from 0 to pi over 4 of sine x dx. And I tell my calculus students this little tool called Snow Cone Santa Claus, SCSC, and the minus signs below. And when you integrate, you rotate around this diagram in a counterclockwise direction. And so the integral of sine is negative cosine. The derivative of sine is going to be cosine. For the derivative, you go in a clockwise direction. So working below, our integral of sine x is going to be negative cosine x. And we're going to evaluate between from a to b to a, right? It's b. So from 0 to pi over 4. And so continuing below, we're going to have negative cosine of b, which is going to be negative cosine of pi over 4, minus negative cosine of 0. And so this is going to be big F of b, and this to the right is going to be big F of a. And continuing to work below, we have negative, and what is the cosine of pi over 4? It's going to be square root of 2 over 2. You should know your unit circle, I hope. We have minus, and our cosine of 0 is 1. So we have minus, and we preserve this negative sign, minus negative 1. And working the right, we're going to have negative square root of 2 over 2, minus negative 1 is plus 1. So this is going to be our answer to this particular integral. Okay, our next problem, the integral from 0 to 1 of e to the power of negative 4x dx. Well, the integral of e to the x power is simply e to the x. But we have this negative 4x here that complicates the issue. So what we're going to do is make a u substitution. We're going to say let u equal negative 4x. So then we have du is equal to negative 4 dx. And solving for dx is going to be equal to negative 1/4 du. And so now we can substitute in for negative 4 dx, we can substitute in for dx. And this is what we get. Working below, we get the integral from, I'm just going to forget the limits for right now. I'm going to put in e to the u power, and substituting in, we have negative 1/4 du. Now, one thing we can do is continue and take the integral and then substitute in the limits after we replace the u with this negative 4x. But one thing that would be quite helpful to us is to change these limits. Now, these limits, okay, limits or boundaries of 0 and 1 are in terms of x. What would help us very much is to be able to change these limits to be in terms of u. So working below here, we can say if x equals 0, which is going to be this a down below here, we're going to have u is equal to negative 4 times 0. So that would be u is equal to 0. So we can replace this lower limit 0. If x is equal to 1, u is equal to negative 4 times 1. So u would be negative 4. And so now we can replace this other limit with negative 4. And working below, I'm going to take this negative 1/4 out front, and we're going to have the integral from 0 to negative 4 of e to the u power du. And then we'll have a very simple integral like we showed at the beginning. So we have negative 1/4 e to the u between 0 and negative 4. And continuing to work to the right, we have negative 1/4 e to the negative 4 power, and we're going to subtract out. Now you notice when I subtract out and do the big F of a, I always like to use a parentheses here just to make sure I have things right. Then we're going to have e to the 0 power. So this is going to be our f of b, and this on the right is going to be our big F of a. So continuing to work to the right, we have negative 1. I've put 4 down here, and e to the negative 4th power is going to be e to the 4th power like this. And then what we have here is e to the 0 power is 1. So we're going to end up having negative 1/4. So we have plus 1/4. And this is going to be our answer. So use substitution. Very necessary to be able to do what we're doing now. Next problem, 4. We have the integral from the natural logarithm of 2 to 3 of 5 e to the x dx. Now I'm going to continue to the right and bring this 5 out front. So we have natural logarithm of 2 to 3 e to the x dx. Well, the integral of e to the x dx is going to be simply e to the x. So bring up the 5, e to the x, and we're going to evaluate between natural logarithm of 2 and 3. So we're just carrying these, that b value above and this a value below. And continuing to work to the right, we're going to have e to the power of, e, can't forget that 5, 5 e to the power of 3, and that's going to be our f of a, and we're going to have minus 5e to the power of natural logarithm of 2. And so coming down from here, we're going to have 5e cubed, and e to the power of ln, the e and the power of ln will cancel each other, so we're going to have minus 5 times 2, which is going to simplify to 5e cubed minus 10. So this is going to be our answer to this problem. Next, problem 5. We have the integral from 1 to 2 of x minus 4 over x squared. I'm going to come down below, and we have two separate terms in the numerator and a common denominator. So we have an integral that we can split into two separate integrals. So we're going to say this is going to be equal to the integral from 1 to 2 of x over x squared dx, and we're going to have minus the integral from 1 to 2 of 4 over x squared dx. And just simplifying to the right, we have integral from 1 to 2, and this x over x squared simplifies to 1 over x. So we have that, and we're going to have minus 4, and over x squared simplifies to x to the negative 2 power, again 1 to 2 dx. And I'm going to work below here. I think that'll give us more room. So we're going to have the integral of 1 over x dx is going to be natural logarithm of absolute value of x. And we're going to have minus 4. We're going to have x to the power of negative 2 plus 1 is going to be negative 1 over negative 1. And we're going to be going for our limits of integration from 1 to 2. So we put these back into a single term. And working to the right, we're going to have natural logarithm of absolute value of x plus 4 over x, because x to the negative 1 power is x in the denominator, that we have from 1 to 2. And working to the right, we can plug in 2. So we're going to have natural logarithm of 2, the absolute value of 2, which is 2, plus 4 over 2. And this is going to be our f of b, big F of b, minus, we're going to put natural logarithm of 0 plus 4 over 1. Okay, so what we're going to have here is natural logarithm of 2 plus 2 minus, well, the natural logarithm, I put natural logarithm of 0. I should have put natural logarithm of 1. Natural logarithm of 1 is equal to 0, so that really doesn't even count. So we have minus 4. And that's going to be equal to natural logarithm of 2 minus 2. And this is going to be our answer. Now be careful, it's easy to make mistakes. making this video, I've made several. I've done it more than once. Okay, here we have more of a conceptual problem. If the integral from a to b of f of x dx equals a plus 2b, then the integral from a to b of f of x plus 5 dx equals. We're going to separate this integral here into the integral from a to b of f of x dx, and we're going to have plus 5, the integral from a to b of dx. Well, we should see that this integral from a to b of fx dx should look familiar. That's at the beginning. So we know that we can replace this thing right here, a plus 2b equals that. So we can say a plus 2b in place of this integral here. And now we've replaced that, and working to this one on the right, we're going to have plus 5, and we're going to have x, and we're going to evaluate from a to b. And that's going to be equal to a plus 2b, and we're going to have plus 5b minus f of a, minus 5a. And so for this, we're going to get a minus 5a is going to be negative 4a, and b plus 2b plus 5b is going to be plus 7b. And this is going to be our answer here. Now the last one we're looking at says, using substitution u equals 2x plus 1, the integral from 0 to 2 of the square root of quantity 2x plus 1 dx is equal to. So if we say let u equal 2x plus 1, then du is going to be equal to 2 dx. And therefore dx is going to be equal to du over 2. And so that means that of these multiple choice answers, the only ones that are going to be possibilities for us are ones where we have the fraction 1/2 involved, which are going to be answer choices A, B, and C. So answer choices D and E are eliminated. In the remaining answers, what we see are different limits after doing that U substitution. So let's figure out what we're going to do. Okay, we have let u equal 2x plus 1. So to take the lower limit, if x equals 0, then u is equal to 2 times 0 plus 1, or u would be equal to 1. And where do we see a lower limit of u equal to 1? Right here. For the upper limit, if x is equal to 2, u is equal to 2 times 2 plus 1. So u is going to be equal to 5. Where do we see that happening? Right here. So our answer choice for this one is C. So that's quite a bit today, quite a long video, very important, kind of, if we had to pick up one stereotypical or caricature of calculus, what a person would imagine calculus to be, my guess is this would be it. I hope this has been helpful to you. It's very important. Good luck, and thanks for viewing.